Hello, and welcome to the Johnson Controls Blue Water webinar for June 2022. Each monthly webinar is an interactive digital experience for water utilities to learn more about new technologies, software, services, and best practices in a vendor-neutral format. The Blue Water webinar is brought to you by the Water Infrastructure Technology team of Johnson Controls. I am Craig Hanna, and I am blessed to serve as the engineering manager of this wonderful team. I have been designing projects that reduce both real and apparent water loss, that increase staff efficiency, and that decrease operational and maintenance expenditures for water utilities for the past 20 years. And joining me today are two of my invaluable colleagues, Audrey Noel and Jonathan Gunn. Audrey leads our team from sunny Southern California, and she is both a whiz at databases and a top-notch project manager. Audrey, would you please tell us more about yourself and how you serve the water industry?
Absolutely. Thank you, Craig. As you said, I'm Audrey Noel, and I am the Business Development Leader for the Water Infrastructure team here at Johnson Controls. I have about 6 years of industry experience, just turned into 7 last month. And sitting to about, 3,000 miles and 3 hours ahead of me is our market manager, Jonathan Gunn. And Jonathan, by the way, congratulations on being named the chair of the AWWA Customer Metering Practices Committee last week.
Yeah, thank you very much, Audrey. It's definitely a humbling honor to be able to lead that committee, and one that I've been a part of for many years, so I appreciate that. So, and as Audrey mentioned, I am Jonathan Gunn. I'm a market manager with the Water Infrastructure team here at Johnson Controls, and as you heard, I am involved with AWWA. I also co-author a number of manuals and publications as well, so appreciate all of you being here with us this morning. And in our typical pattern and style here, for those who may be new to the webinar series, I did want to briefly review the console in front of you just so you can be acquainted what you're seeing here. And as I go through this, you should see some orange dots popping up on your screen here. So the main window here, the biggest window, is the slide deck. This is where you'll see a majority of the action as we go through the webinar here, as we all the slides, all the information as we talk through it. This is to the left of that, you'll see the media player. That's where you're currently seeing my video feed, and you'll see the video feed of the other presenters as we move through the webinar. Beneath that is webinar-related content. So this is all, these are files that you can download and read at your leisure that have to deal with supplemental information about various topics that we'll be discussing today. To the right of that, you have the Attendee Chat. So this is something that's been new the last couple months, where you can chat with your fellow attendees that are here on the webinar with you today. I will note that if you're trying to ask a question to the presenters, we are not able to see this chat. So if you do have a question for us, there are a number of ways you can ask that. Immediately to the right is the Ask a Question box. So that is something that will come right to us, and those questions we'll try and get to right here on the webinar. If you feel that a couple sentences there just won't quite do it, at the top right we have an email feature. So this will send an email right to our inbox at bluewater@jci.com, and we can you can expand upon your question there, or if you feel it deserves a verbal conversation, it's just something that you really want to talk through and pick our brains a little bit verbally, more than happy to have that conversation with you. Just use the book a meeting function here and set up a time on our calendars, and we'll help you in whatever way we can. Last but not least, along the bottom, you have the icon bar. These are for all the available windows that you can see, and you'll notice some of them are a little redundant here. So all of these windows that you see in front of you, you can move them around, you can scale them, resize them, really make this experience your own. If in doing so you accidentally happen to X one of those out and get rid of it, just go back to that icon bar along the bottom of the screen. You can bring it back, no problem. There are also a few others that are currently not up, such as the earning CEU credits. You are eligible to earn those continuing education credits. Just click that icon, fill out the form, and we will get you a certificate with all deliberate speed. There are reactions as well, so you can give us a thumbs up, thumbs down, whatever you want during the webinar. If we really say something that hits home with you and it makes sense and you appreciate. And then last but not least, taking a survey, something we always ask after every webinar. Let us know how we did, what did you like, what didn't you like. We are always trying to make this webinar series better, and that's a big help for us to be able to do that. So all that being said, Craig, I'll throw it back to you. Do you want to take us through the agenda?
Yeah, thank you, Jonathan. I'll be glad to do that. You know, today is the first full day of summer, and depending on where you live, the weather is either probably hot and dry or hot and humid. I myself was born and raised in a very hot and humid part of the country, but I later moved to a very hot and dry climate, and I confess to having learned a very painful lesson, and that you must drink plenty of fluids in a hot and dry climate if you want to stay healthy during the hot summer months. Believe me, I tried never to make that same mistake. We've asked our good friend Andy Crocker from the Southeast Rural Community Assistance Project to return and give us a lesson in working safely outside in the heat. And as many of you know, we covered the fundamentals of leak detection in our webinar last month, along with both valve-mounted and service line-mounted automated leak detection systems. We're concluding our series on real water loss reduction strategies with some alternative approaches such as smart fire hydrants, smart water meters, satellite leak detection, the Ecologics ePulse system, and traditional acoustic leak noise surveys. Next, we'll ask our good friends Jeff Cunningham and John Van Arsdel to join us for an interactive discussion about the many great services that the ME Simpson Company, in partnership with Johnson Controls, can provide to your water utility. We will then review our experiences at AWWA ACE before we close. And while we're talking about ACE, I have to say, other than Jonathan Gunn's 2 technical session presentations, what were your best learning moments or favorite new products that you discovered at AWWA ACE? And you should see a pop-up window on your console. And if you'll just let us know what you thought were some of the better points of ACE last week, we'd sure like to know about that. And in a minute, we'll be talking about the importance of asset management and valve exercising programs, and that was clearly demonstrated for all to see last week in the city of Odessa, Texas. The city experienced a break on a 24-inch main that had been in service for about 60 years, and according to news reports, the city crews tried to isolate that section of main by closing the valves in the area, but that effort was unsuccessful because some of the valves were inoperable. City officials had no better alternatives but to take the water treatment facility offline, leaving 165,000 residents without water for more than 2 days in the late spring weather, with high temperatures ranging from the upper 90s and lower 100s. Repairing the main break itself required nearly 34 hours to complete, and the boil water notice remained in effect for 5 days after the break. And like I said, we'll talk more about the importance of these type of programs later in our webinar. And now I would like to introduce to you Andy Crocker from the Southeast Rural Community Assistance Project, or SRCAP. Andy is the Virginia State Manager for SRCAP, and he has been involved in providing training to water utility staff for many years. Andy, we are so glad to have you on our webinar today. And what are some of the things that we need to know about working safely outdoors during the hot summer months?
Well, thank you, Craig, and it's a pleasure to be here, and I appreciate the opportunity to share. What I'd like to speak about just briefly, and we could spend quite a lot of time actually talking about it, so I'll share where a lot of these resources are available. But working in the heat is something that folks sometimes take for granted without understanding that there are special steps that they ought to take, both regarding heat stress prevention and how to respond to symptoms of heat stress related illnesses. So I want to just talk a little bit about some of the things that need to be considered and some of the signs of heat stress related illness, and then how to respond to those briefly. Like I said, there's a lot of information, but I'll just share a few points briefly. A lot of folks will get up and listen to the weather and maybe even seek out what the heat index is for a given day, and then make decisions about working or work conditions related to that information. And while that is a good place to start, that isn't necessarily the best information regarding what the conditions might be at your individual work site. For example, the heat index is measured by weather services. It's the ambient air temperature and the relative humidity as measured in the shade. So that may not be reflected of many job sites. And depending upon whether or where the measurement is taken, it could be a considerable distance from where you're actually working. So there are other factors that contribute in addition to the temperature to heat stress or risk of heat stress to workers. So in addition to the environmental factors, there's the presence of other heat sources. Particularly, I think of folks, and you may think also of folks who are working on road projects or working on roofs and those kinds of things. But when you're repairing a water line or installing service lines or any of those places where you might be near heat, like pavement, and the heat that's reflected or collected and reflected from that, that obviously will increase the heat index for your site. The level of physical activity, the workload increases the heat load in your body, or your body's heat production, I guess I should say. The clothing, you need to be mindful of the types of PPE you're wearing. Some of it may not allow heat to escape, so you'll contain that heat and it'll add to your risk factor. And then some of you may experience individual health personal risk factors, and they include obesity, high blood pressure, diabetes, and other things that could potentially make you at higher risk for heat stress related illnesses. So I guess in summary, there are two factors that have to go into heat stress related illness, and those are the environmental, as I said, and then the metabolic heat that is generated by your body based on your workload. There's a stat that is actually on EPA's website that people have actually, and where did I see that here? Hold on just a second. With regard to heat index, there have been folks who have died from heat stroke when the heat index was only 86 degrees. So heat-related stress and illness for heavy workload-related tasks can result even at temperatures with a heat index of 65 degrees or less. So this is pretty serious stuff. You need to make sure that you take those things into consideration. I guess prevention, planning, supervision under those kinds of things. You really need to have a heat illness prevention plan, and things like who will provide oversight of that on a daily basis, how will new workers gradually develop heat tolerance, the plan or what is enacted for different workers would be based on whether or not they're acclimated to these conditions. But just because you might be used to working in the heat doesn't mean that you still don't need to take regular breaks, stay completely hydrated, monitor your physical responses to what's going on, all those kinds of things. The supervision needs to be able to identify and control heat hazards, recognize early symptoms of heat stress, be able to administer first aid for them or activate emergency medical services when necessary. So some of the different things, if you had any OSHA related training, you know that they break things down into engineering controls and work practices and PPE. So some of the engineering controls will be provided cooling breaks, and they might be a cooling station. I had some pictures that I wanted to send Craig and I just didn't get to. I've seen like these canopies that people set up in their yard. They're 10 by 10, 12 by 12. I've seen people use them at tailgates for ball games and things like that. where it just provides some shade, and there's some battery-operated fans that are actually pretty easy to get now, like at Home Depot and things like that, if you don't have power available on the work site. Misting sprays, different things like that. Work practices might be moderating the length of your shift, rotating jobs that are high stress, high exertion and high heat exposure, and lots of different things like that. Being careful about your personal protective equipment. Again, be conscious of those vests and other types of personal protective equipment that do not allow heat to be released from your body, and take special care. I feel like I've been talking an awful lot, and I realize that I have, and I've just barely begun to scratch the surface. But all of these things are important to consider, and I've just put in the chat where you can find a lot of this information and much, much more at this particular website, osha.gov/heat-exposure.
Yeah, thank you, Andy. It's phenomenal information, and we definitely appreciate you being here with us this morning and sharing your passion there. So we definitely, good tips. I know here in New York, it's about 92 degrees today, which I know there are probably a number of people on the call laughing at me for that one, but we're laughing at you guys when you're bundling up at 50 degrees. So, it's just my time to be the butt of the joke there. So thank you, Andy. We appreciate it.
Thank you, guys.
So,
have a great day.
You too. So before we begin our second installment of distribution leak detection methods, let's quickly review how most distribution leak detection systems work, as we discussed in our webinar last month. So for those systems which utilize acoustic leak detection technologies, it's all about energy transfer. Water distribution systems are pressurized, and whenever you pump water, you transfer energy from the motor to the pump and into the fluid. If there's an opening or orifice in the pipe downstream, that equates to another transference of that energy. We discussed how some of that energy becomes an audible noise due to the turbulence as the internal and external pressures seek to reach equilibrium. How some of that energy becomes a pressure wave that erodes the backfill supporting the pipe and creates possibly a cavern around the pipe. And how some of that energy becomes a mechanical vibration that radiates up and down the pipe from the leak site. We also discussed two main types of systems, valve-mounted and service line-mounted systems, and how those technologies capture those vibrations and use sophisticated software to analyze the frequencies for potential leaks. Additionally, we indicated that there are two things you need to remember about acoustic leak detection. The first is that vibrations on metallic pipe may travel up to 1,000 feet under ideal conditions, but vibrations on non-metallic pipe will only travel about half that distance. The second thing is that acoustic leak detection is only effective on pipe that is about 12 inches in diameter and smaller, since the pipe wall thickness quickly dampens any vibrations from a leak orifice once you get any larger than 12 inches. This led to an obvious question of, well, how do you detect leaks on some of those larger diameter pipes? Well, this month, we will discuss some alternate methods of finding leaks in your system. Some of these methods will use acoustic technologies, much like what I'll call more of a mainstream valve or service line mounted system. Only they use different methods of installation, while other methods take a vastly different approach, as you will see. Also, before we begin, we did want to share another good vibes, pun intended, vibration type, story with you this month. If you joined us for our May webinar, you may recall a discussion about a circumferential break on an 8-inch cast iron pipe that we discovered at a military base in Canada. That break was leaking at an approximate rate of 310,000 gallons per day and costing the customer over $1 million a year. Well, we completed another acoustic leak survey in late May, this time for a correctional facility in Oklahoma, and we found 5 leaks that were wasting an estimated 93,600 gallons per day, or 34.2 million gallons annually of treated water. At a rate of about $9.38 per 1,000 gallons when you combine the water and sewer charges, those 5 leaks were costing the citizens of Oklahoma on over $320,000 a year. Needless to say, the facility is very happy to have that revenue back so they can make other much needed upgrades and improvements. Also, briefly here, a couple different surveys here we've spoken about in the last couple months about large breaks. We're curious, what is the largest leak or break, in terms of a flow rate at least, that your utility has ever discovered? If you wouldn't mind, there should be a pop out here for you. just answer, it's a free answer here in the box there. We're going to keep moving here, but we are very curious just what are some of the largest breaks that you've seen, and if you wouldn't mind sharing those with us. All right, so it seems that most every device on the market today is now available with some degree of intelligence, and fire hydrants are certainly no exception. Your trusty fire hydrant can now be used to identify leaks in the distribution system, and some fire hydrants can also be used to monitor distribution system pressure. Depending upon the manufacturer and the model, these features can be retrofitted to an existing fire hydrant as well. Most manufacturers install the leak detection sensors, a battery pack, and either an LTE, Cat M1, or NB IoT cellular radio onto a composite pumper nozzle cap. The first smart hydrant that we will cover is the Mueller Super Centurion with Centric software. Both leak detection and pressure monitoring are available on new hydrants, and a retrofit kit is also available for any Mueller Centurion hydrants with buried depths between 3 feet and 7 feet, and a date of manufacture that is after 1975. Leak detection can be added to any Mueller hydrant by replacing the existing pumper nozzle cap with a leak detection enabled nozzle cap. These features are available on both dry barrel and wet barrel hydrants from Mueller. Pressure transducers are enshrouded within the lower stem, and through porting can capture data while the main valve is closed from the water in the hydrant shoe and network. A new lower stem is included in the retrofit kit, and the battery pack should provide your utility with approximately 10 years of service. The Ecologics EchoShore-DX system combines the leak detection system from the fire hydrant pumper nozzle cap with an EchoShore-DX E sensor that is magnetically attached to virtually any access point on your water network. These remote sensors backhaul the acoustic data from each sensor every night over the LTE, Cat M1, or NB IoT cellular networks. Using both sensor types creates a system-wide sensory network to find leaks in the distribution system. One consideration for the EchoShore-DX system is that it is programmed to find leaks on metallic pipe only, and has not been programmed to detect leaks on non-metallic pipe. Orbis has entered the smart hydrant market with two products. The smart cap that you see at the left of your screen replaces the existing pumper nozzle cap and allows most any dry or wet barrel hydrant to provide alerts for unauthorized usage or tampering and to identify leaks within the distribution system. The smart cap has a replaceable battery, and it communicates through an LTE Cat M1 cellular radio. The Orbis smart hydrant that you see on the right of your screen provides a built-in multi-sensor to detect an array of pipe and flow conditions, such as alerts for unauthorized use and tampering, leaks on the distribution system, temperature monitoring, flow events and alerts, and both vibration and seismic monitoring. The Camstrut Flow IQ 2200 water meter is another acoustic technology which serves as an alternative to traditional valve or service line mounted systems. This is a modified version of their Flow IQ ultrasonic residential water meter, as it has the added capability of recording vibrations. This meter is available in sizes 1 inch and smaller and transmits the water usage, water temperature data, various alarms and alerts, and the vibration frequency history through the proprietary Camstrut AMR or AMI system. Using the Camstrut mobile AMR system, the acoustic leak noise data is recorded at the instant that the meter is read. Using the Camstrut fixed network AMI system, the acoustic leak noise data is recorded daily. Camstrut then analyzes the acoustic leak noise data using proprietary software and provides your utility with a map-based overview of your supply area. The map shows each Flow IQ 2200 meter with a color coding that represents the noise level registered, and the corresponding graphs that illustrate how the frequency is changing over time. These are examples of those graphs. The graph on the left side of your console shows a leak on a service connection. Notice how the leak level, noise level was very low until the leak formed, and then once the leak occurred, the leak noise level remained relatively constant until the leak was repaired. The graph on the right shows a leak on a service connection that was about to expand into a burst pipe. And as you can see, the noise level was initially quiet until the leak formed, and then once it was there, the noise continued to increase steadily over time, which indicated that a burst pipe was imminent. Thankfully, this pipe was repaired before that happened. In this example, 3 different meters recorded the vibrations from this leak on a fire hydrant. As you can see, the leak noise pattern is remarkably similar between the meters, but the distance from the meter to the leak site affected the noise level that each meter was able to record. To that point, the Camstrut leak detection system should work well in dense urban areas, but there may be gaps in coverage in commercial and industrial zones, parcels with large lot sizes, and residential areas that are sparsely populated. something that can be said of traditional valve mounted or service line mounted systems as well. Audrey, would you mind showing us some of the alternate methods which may be considered?
Sure, thanks, Jonathan. Well, the next 3 leak detection solutions we're going to present are contracted services. There's no equipment for you to purchase, and your staff does not need to receive any specialized training. One of these service offerings can even provide you with the remaining wall thickness of your metallic pipes. Your utility can include any of these technologies in a performance-based contract with Johnson Controls and have a budget-neutral way to fund these improvements over time without raising water and sewer rates or passing a bond. Use the Contact Us module or the Book a Meeting function on your console if you'd like to learn more. Asterra, formerly known as Utilis, uses satellite imagery to find leaks in both fresh and treated water pipes, as well as seawater intrusion and sewage exfiltration. Launched in 2016 and orbiting the Earth from an altitude of 390 miles, the Asterra satellite uses L-band synthetic aperture radar. One pass can cover an area of up to 1,400 square miles. An L-band synthetic aperture radar can penetrate through forest, pavement, asphalt, and concrete to a depth of up to 10 feet, regardless of the local weather conditions and the available daylight. A second pass over the area to be surveyed is often flown 14 days after the initial pass to confirm those results. Satellite leak detection is effective because seawater, sewage, treated water, and freshwater each has a very distinct dielectric constant at L-band radar frequencies. Once the images are received from the satellite, Asterra converts them into data pixel values. Those pixels are then translated into points of interest as seen in the yellow dots in the image on the left-hand side of your slide. Those points of interest are then overlaid on top of a GIS map of the water distribution system as seen in the image on the right-hand side of the slide. Each point of interest is a circle with a radius of 300 feet. A crew with a leak noise correlator and a ground microphone is then dispatched to the pinpoint of the leak site in each point of interest. Asterra claims to have an 80% success rate in finding a leak in a point of interest. ePulse by Ecologics is a system that's designed to provide both pipe wall thickness and leak detection on metallic, asbestos, cement, and concrete pipes. Because of how sound waves travel through non-metallic pipes, this technology is not designed for use on PVC or HDPE pipe. The ePulse system works by installing sensors on accessible fittings and hydrants throughout the distribution system with between 300 and 500 feet spacing between those sensors. The technician generates a sound wave by either tapping on a fitting with a metal hammer or opening a hydrant. The sensors then measure the speed of the sound through a pipe segment, and those measurements are translated into an average pipe wall thickness value. Any leaks on that pipe segment will also be identified and correlated. At the conclusion of the analysis, Ecologics or their approved providers will draft a report that grades the pipes in your distribution system. Based upon the results of that analysis, you'll know which pipes merit immediate replacement to prevent a catastrophic failure, which pipes are in poor condition and should be replaced within the next few years, and which sections of pipe should be included for replacement in the next capital improvements plan. Jeff Cunningham and John Van Arsdel from our trusted partner, the Simpson Company, will join us shortly to tell us more about both the ePulse system and our last leak detection service, which is traditional acoustic leak noise surveys. Craig, that must be a very old picture of you. There's not a gray hair on your head.
Yeah, yeah, that photo was taken a dozen years ago when I was first learning how to use a ground microphone. And no, I am not wearing a reflective safety vest in the photograph because the street had been barricaded for use in our training that day. And in fact, I would like to mention to anyone in our HR department who may be in the audience that none of the Johnson Controls personal protective equipment policies that we are required to follow today were in effect back in 2010 when this photo was taken.
Good point, Greg. Well, we've shared some very innovative leak detection technologies with you in both this webinar and the webinar from last month. But we know from experience that these real water loss strategies may not be for every utility, and especially for smaller utilities with very limited staff. That's why we want to close by discussing conventional acoustic leak noise surveys. Our team firmly believes in acoustic leak noise surveys, and you should know that many of our customers ask us to include them as a key part of our comprehensive water loss optimization project strategy. We recommend that smaller utilities be surveyed annually. Medium-sized and larger utilities should consider sectioning the distribution system into halves, thirds, or even quarters, and then having a qualified firm survey a section every year on a continual basis. A best practice is to survey a section of your distribution system and areas that are known to have problems with leakage annually. I'd like to reemphasize a point I made a few moments ago. If you'd like to have any of the many innovative systems or software programs we've shown to you today or in past webinars, but you don't have the funds available in your budget, please let us know. We have a budget-neutral way for water utilities to fund improvements over a term. Better yet, we offer you a financial guarantee that the systems will perform as designed, which removes the risk for you and your utility. If you'd like to know more about our program, please either use the Book a Meeting module or the Contact Us module on your console. Before Craig has his interview with Jeff Cunningham and John Van Artsel of the M.E. Simpson Company, we'd like to pause for your questions. Please use the Q&A module on your console and ask us for more information on an item we presented today, or maybe clarify something we said.
Okay, well, I didn't see any questions come in just yet, but again, if you have questions, please feel free to reach out to us at bluewater@jci.com, and we'll be glad to discuss these technologies or any others that we can be of assistance to you. And I would like to take this opportunity to introduce my good friends Jeff Cunningham and John Van Artsel. Jeff is the Business Development Manager for the M.E. Simpson Company and Chair of the Indiana section of the American Water Works Association. John Van Artsel is the Vice President of the M.E. Simpson Company and a former chair of the AWWA Water Loss Control Committee. It's so hard to believe that we've been working together for the past 16 years, but we truly value you and the partnership that we have created. And John, tell us more about M.E. Simpson and some of the things that you provide for water utilities.
Craig, thank you very much, and we appreciate the opportunity to be able to work with Johnson Controls for the past 16 plus years. It has indeed been an honor and a pleasure to help assist Johnson Controls in their water loss control efforts. But prior to our tenure with JCI, M.E. Simpson Company has been in business since 1979. The company was founded by Marvin Simpson on the philosophy that he recognized that water loss is equal to money loss for water utilities. And so the basis of the formation of the company was to go and help water utilities recover lost revenue through various aspects of water loss control, such as large meter testing and maintenance, leak detection, and then that blossomed into asset management and further transitioned into total water loss control programs, such as water auditing, getting to the transmission main leak detection programs, and doing condition assessments for water utilities. Our asset management program covers water valve assessments, hydrant assessments, pipeline condition assessments, where we utilize acoustic, non-invasive methodology to help determine remaining useful life on water mains. And in the water loss control arena, we do perform certified water audits, and we have 8 certified level 1 validators certified from California and the state of Indiana to review audit practices that water utilities use. We also have been involved in master meter testing, commercial large meter testing and calibration, transmission main leak detection, leak surveys, leak pinpointing, and 24-hour on-call services. And again, That's all transitioned into improvements of water quality by helping utilities perform unidirectional water main flushing, cross-connection control surveys and inventory, and backflow management and maintenance. Next slide. Our staff is not limited to just doing work. We encourage our staff to be involved with AWWA as well as the local water associations. And so with that, we've involved ourselves with the M6 manual, the M22 manual, the M33 manual, the M36 manual, and the M77 manuals. This gives real life experience to what we do, and it allows us to have some input into how utilities can best utilize the data that gets collected in the field on their behalf. Our staff has held offices with AWWA. We have 2 past AWWA vice presidents, a current AWWA director. We have 5 past section chairs for Illinois and Indiana, and of course involved in various section committees. We've won several and numerous AWWA section awards, and the most notable is we have 4 George Warren Fuller awardees. Next slide. Water produced never equals the water consumed. So what you pump into the system never equals water sold. The age-old question is, well, where did it all go? Next slide. Well, believe it or not, water loss control has been around since the Romans and even prior to. Julius Frontinus was the first Roman water commissioner, and he recognized the importance of equitable water distribution. The Romans would use a brass or bronze Roman adjutage, which was inserted into canals and measured flow as it went into farmers' fields. And they would measure the flow over time to give farmers an allotment of water based on the size of their fields. Next slide. The cost of water loss is humongous when you consider our modern day technologies that we have available to us. There's a lot of physical damage. There's interruptions to commerce and environments. There's water quality issues that can occur. And all of these things come to play when you have water loss. Next slide. On top of that, it affects the labor force that water utilities have to deploy in order to do their jobs day to day. It also puts strains on supplies and equipment. And then, of course, there's always the issue with the water supply. And anybody who lives in the western states of the United States fully understands the ramifications of that. Next slide. The customer, the end user, they're the ones who offer an interesting perspective, because when you have water loss, it really does heighten the inconvenience from the water interruption of services and affects commerce. If you could imagine the water main break that Craig discussed in Odessa earlier, how that affected the local hospitals and how did they manage to do without the water in their area during that time. It brings unwanted negative publicity. Nobody wants to have to deal with Channel 5 News in their helicopter hovering above a major main break somewhere. It just is not good optics for the water utility. But it also, we run into the issue of where metering is inaccurate, then you have inequities that occur with water distribution. Next slide. We're going to talk here about leakage assessments and how we approach that. Next. We've been doing this work for over 41 years in all types of weather, from minus 20 degrees below zero to 110 degrees in the summer. Nothing beats the perspective of having to deal with a major leak when it's 14 below zero, 2 o'clock in the morning on Christmas Eve. Folks, this is it's a real education and it's a real experience. When I had to do it, back in the day. So we've encountered all sorts of types and sizes of water systems, up to systems that have 7,700 miles of water main, down to little systems that only have 1 or 2 miles of water main. We sent and deployed crews to Italy, Turkey, Diego Garcia, Guantanamo Bay, Cuba, Alaska, and all points in the continental U.S. We service all types of clients, both municipal and some private. We're constantly evaluating the newer technologies, and we follow an extremely strict methodology for doing leak detection that produces results. We run a 24-hour emergency leak service in the Chicago Metro, and we cover southeast Wisconsin and the Indianapolis metro area as well. Next slide. This particular slide shows a 72-inch water main break that occurred in 2010 in Baltimore. This one definitely made the news because the city wound up having to shut down services to a major portion of the city. The end result of this, because it certainly did look like an ocean out there, they bought 150 cars, 100 homes, and a couple of strip malls to boot. Then you have these little leaks that don't make the news that run forever and ever. And when you look at this over time, this little leak can run for 2 years, 5 years, 10 years even, and actually it can you can lose more water through this little leak than you do with this big leak, simply because this big leak, the awareness of when it occurred and when it ruptured is pretty short in terms of the timeline. Next slide. This is an example of 2 pieces of equipment that we use. We use a leak correlator, and then we also deploy a non-invasive large diameter acoustic water main leak detector for the large diameter mains. Next slide. Performing leak detection is mathematical, and so the sensors that detect the vibrations on the water pipe pick up the noise or the sound wave as it travels down the length of the pipe. And by cross correlations, we're able to determine and pinpoint where the leak is. And it is through this process that we assume that the leak is actually dead center between these 2 sensing points. We know that's not true. So what the computer does is it measures the time delay difference of the leak noise reaching one sensor versus the other. And that time delay difference mathematically translates to the location of the leak. Next slide. We then collect all of the data and put it into a GIS format for utilities to use, and we can supply them with a map that shows where the leaks are occurring so that they can deploy crews on a as-needed basis to go out and repair the leaks. This becomes a permanent record for them to look back on and record their history of leakage. Next slide. The ePulse equipment is a non-intrusive methodology for measuring vibrations on pipes to determine pipe wall thickness. This technology was derived from, believe it or not, the actual leak correlators that were used to detect leakage. And the manufacturer of the ePulse equipment, Ecologics, had taken this methodology and really souped it up on steroids, so to speak, and made this equipment available so that it could be used to do a non-invasive analysis of the pipe materials. Next slide. The value of large diameter leak detection can't be understated. By finding small leaks on big pipes before the pipes rupture is a very valuable thing to have available. Next slide. Again, this is just a showing of the ePulse equipment. Next slide. The value of pipeline condition assessment comes about as a result of conducting the ePulse surveys on selected mains. What this does is it allows the utility to really look long and hard without having to dig anything up as to the potential of what mains may have to be replaced over time. If we find an area of mains that need to be replaced according to the analysis, they can conduct further analysis by actually doing a sample and taking a core sample off the pipe to investigate it, such as a coupon. Next. Now we're going to talk about production meter assessments real quick. Next slide. To help in the water loss arena, one of the first areas that utilities need to look at are the master meters for the water utility to determine the actual water production. And the only way to do that is to really test the meters to determine the true volume. We recommend that this be done annually. Next slide. We've got 41 years experience in doing this, and we've been involved with AWWA in reporting back to them with data that we've acquired over the years. We can test with our methodologies up to 108-inch diameter meters, about the size of my house. We understand the strict methodology that needs to be applied to field evaluate and test meters beyond all the AWWA specifications. Next slide. What's the test data used for? Well, anybody who does a water audit can take the water supplied that they have acquired over the entire year and apply the meter accuracy for an actual corrected number. If you don't get the number correct for the water supplied area at the very beginning of the audit, the end of the audit will be incorrect. So that number needs to be solid. Next slide. Here's a list of reasons for meter failures: age, mechanical wear, corrosion, mineral buildup, and so forth add to the reasons for meter failures. And the consequences of that are inaccurate billing, lost revenue, over or under chemical applications, and an error in the annual water loss. Next slide. We use a Pitot Tube, which has been around for over 100 years and was designed by Ed Cole. It's based on the principles discovered by Henry Pitot during the late 1700s in France, who figured out that by inserting a tube into the water to face the upstream to measure the current inside in a river, he was able to determine using Bernoulli's equation how fast the water was moving through that. So by determining the area of the pipe and where the Pitot rod has been inserted, we can determine the area and then measure that flow over time to determine the volume. Next slide. Most utilities have had a practice of removing meters, master meters, but annually to ship them to a factory for recalibration. But you can't do this with Venturi meters this size. So it comes down to, are we able to get in and test the meter on site, testing under the conditions of which the meter is being used. Next slide. We can come on site and we can do it. And we can also check the DP cells and the sensors right there while we're doing the test. Next slide. Flow conditioning is an extremely important part of determining meter accuracy. And so when we are on site, we will look at the flow conditions that occur upstream and downstream of the meter. Next slide. This is an example here of what happens in terms of flow conditioning when the meter is improperly configured. As you can see, the flow will be directed to the bottom of the meter, and so the meter will not read correctly. Next slide. Okay, Jeff, you're on.
Hey, John, thank you. And thanks again for the JCRA team for having us on today, and also for our many years in partnership. It's really been great to work with the team and help so many utilities across the country increase revenue and optimize performance of their system. And real briefly, I'm going to touch on a couple things. You'll see me buzz through a couple slides here to keep us on track. But in talking about commercial industrial revenue meter testing, so a little different than the production meters, ideally those are tested in place with a certified test meter for a comparative test. And as we're out looking at meters and see lots of these things, it's not only the testing of the meter that becomes so important. We're looking at things that are often untouched. As we all know in our industry, so many of our assets are out of sight and out of mind. And this is an example of a meter pit we found in a survey. And actually what this had 13 2-inch meters manifolded together in this huge pit that you can see this person at the other end of. Now, this was feeding a resort, so it had a hotel, restaurants, pools, facilities, fire protection, all kinds of stuff. So from the utility standpoint, for a lot of years, this was great. Out of sight, out of mind. We're getting good reads. We're getting good billing. In reality, in all practicality, this was a horrible installation, and someone had done years ago in an effort to try to save some money. Instead of putting in a large, properly sized meter to allow for flow, head loss, fire demand, all those types of things. So again, from the utility standpoint, for a lot of years, this was an out of sight, out of mind thing. Here's another example of something we've come across often in looking at commercial inspections. So what you see here is an older Hershey fire service fire flow meter. So in these cases, you have a high flow. They're almost like a big compound. You have high flow side that's made to open with an internal valve when demand's high for fire. On the low side, you've got a traditional compound meter that takes care of normal domestic usage and recording normal flows. What we find often, and this is an example, someone has retrofitted that low side meter with a new meter that's not even from the same manufacturer. So flow characteristics, hydraulic flow design is different in this meter. Well, what happens, you're potentially affecting when that high flow may open. And so you are possibly interfering with fire flow at the time the demand needs it. Another thing when we come across this kind of stuff, and often utilities don't realize it, these are certified by UL and FM to be installed in fire protection systems. You change anything about the design, you voided that certification, potentially opened yourself up to liability. So again, these are the types of things in looking at meter programs. We're not just looking at the cash register. We're not just looking to improve revenue, but we're also looking at making sure the system's working correctly, flows, availabilities are available, and demand can be met for the customers. In field testing, we often see a lot of times that meters aren't properly set up for testing. Sometimes we have to add test ports, work with the team to get accessibility. Sometimes we found inlet and outlet valves that aren't always set. But in a quick snapshot, this is a picture of a vault with a compound meter, kind of an ideal setup. You've got a test port on the meter, you've got inlet and outlet valves, and also important, you have a bypass. And so these are the types of things we're looking for. And obviously, when we're working with the JCI team on a project, we are replacing and updating meters. We want to leave them for future maintenance, set them up correctly so that ongoing testing can be done. And of course, John touched a little bit on the production meters, but we're talking about different things that impact the meter, and the importance of commercial industrial meters. Testing them in place is really critical because you're testing the whole setting, not just the accuracy of that meter. Because remember, installation can affect accuracy. One of the other things we do a lot of is valve assessments, and I think ultimately Craig hit on it right out of the gate as we talk about the recent issue in Odessa. Again, out of sight, out of mind. But any valve in your distribution system is made to be operated by one individual operator or technician with a manual valve wrench. So at midnight, when it's time for that shutdown, someone can get out, shut an area down, isolate an individual line to repair a leak. What happens when they're out of sight, out of mind? They're never operated. So when that 12 o'clock Sunday morning emergency hits, can't operate the valve. Find yourself shutting down larger and larger areas of the utility of the system, or in the worst case of Odessa, shutting the entire system down. So preventive maintenance on the valves, locating them, assessing them, sometimes valves that have been there for years that have never been touched, or at least in recent memory, going out, assessing them, getting them exercised and back into operation where they're reliable is a key a service that any distribution system needs. And some utilities do a great job of doing this in-house, but as we know, a lot of times you just don't have the resources to cover them in-house. In AWWA standards, AWWA guidance, typically look at critical valves being operated and exercised at least annually, with non-critical being out no more than 4 to 5 years. And again, lots of times it's tough to have the resources to do that. Actually, some states now, as part of an asset management plan, are beginning to require valve exercising as part of that ongoing asset management plan. In this instance, you see a couple of large valves here. The upper left-hand corner, obviously, is a big lay-down gate valve, and the smaller valve on the side is a relief valve. But the key to remember, both of those valves should be able to be operated by one operator technician with one manual valve key. So what happens? You don't operate them, they're stuck, you have to repair them, replace them, or sometimes we'll see you go out for the first time to operate it in the midst of that emergency, and what happens is you end up breaking the valve closed. Again, when you're out operating valves, you may end up having 1 or 2 that break as part of that exercising program, but at that time it's planned and scheduled when you're working on them, not at midnight on a weekend when you're trying to isolate to repair a leak. Hydrants, we do a lot of asset management programs with hydrants, specifically maintenance from a fire flow standpoint, making sure they're operable and ready to go, and also the hydraulic data coming from flow testing the main segments and the hydrants. Also, one thing that we're just bringing in, as Craig and his folks mentioned earlier, we are an Ecologics provider with the ePulse and the EchoShore in certain parts of the country that we work with the JCI team. But also we are working in an authorized service provider for a company called Electroscan that is a scanning tool originally developed for gravity sewer, but now we can also use it on larger diameter water mains, of course, different equipment, keep it clean, and also pressure sewers. But what it does is we look at an electric signal scan through the pipe. So instead of watching countless hours of video and looking at potential cracks or trying to hope that there's a rainfall event when we televise and we can see inflow, what this operates on is the theory that any place water can leak out of or into a pipe, electricity can go out of as well. So we can scan the pipe and literally within minutes see what the pipe looks like, conditions, not going out and videoing and looking at, countless hours of footage hoping to find something. So this is another one of those tools that goes into that leak detection quiver of arrows, I'll say, that Jonathan and Audrey covered over earlier is, there's no one set tool for all leak detection, and it's going to take a combination for any utility to utilize that different technologies to have an all-encompassing real loss reduction strategy. And so with that, I again want to thank the JCI team for having us on and everyone being here. Now, one thing I will want to point out, this is a number that oftentimes folks don't see, is the 6 billion gallons a day, based on multiple surveys from every state, is an estimate of losses, and that is real losses on a daily basis in the United States. So while we've made a lot of big improvements in the last several years, we've still got a long way to go. And you'll also notice on this slide, we touched on a little bit of, or we talk about a little bit of financing options, but we're going to leave that up to July, because the next JCI Blue Water webinar in July will specifically focus on the myriad of funding options and navigating those options or funding sources that are available to utilities.
All right. Well, thank you, Jeff and John. We're so glad to have you and appreciate everything that you've done for us and our customers through the years. And as you just said, we have a very exciting webinar lined up for you next month, where we'll be talking about funding and financing water projects. We've asked our top financing and grant experts, Ben Speed, Liz Charwitz, and Philip Lowry, to join us for a special webinar on how to pay for all this amazing technology. And we know that you'll be here with us on July 20th for this very important interactive event. Come prepared with your questions for these experts too. And we'd sure like to thank Andy Crocker for reminding us all to work safely in the summer heat. Don't make the same mistake of not hydrating properly like I did. Thanks again to Jeff Cunningham and John Van Arsdel from the Simpson Company for joining us today to talk about all the wonderful services that Johnson Controls and Simpson can provide for your utility. And please invite your friends and colleagues to attend the Blue Water webinar next month. And we'd like to thank you for attending the Blue Water webinar. Please be safe, and we look forward to seeing you next on Wednesday, July 20th.